So each Monday through Friday, a work week, there is 5 days, Avinash will bring either exactly one apple or exactly one banana with him to his workplace for an afternoon snack. So exactly one apple or exactly one banana. To avoid having to decide which to bring, each morning, Avinash will toss a coin with the face on exactly one side that is equally likely to land face up or face down. So basically, this is a coin toss, a fair coin toss, right? Equally likely to land face up or face down. If the coin lands face up, then he'll bring an apple. And if the coin lands face down, then he'll bring a banana. Look, they've made the wording a little complicated. They've introduced an apple and a banana in the whole equation. Essentially, this is a fair coin is being tossed and heads and tails, right? So we'll stick to the wording of heads and tails. We're saying that if he gets a heads face up, then he brings an apple. And in case he gets a tail, then he brings a banana, right? Okay, Avinash correctly determined the probability that for a given work week, either he would bring an apple on at least 4 consecutive days, or he would bring a banana on at least 4 consecutive days. Now, there are 5 work week days, right? So I have to select 5 times. So what can be the result of any work week? I know how to calculate, right? Binomial, isn't it? So I'll say there are two ways in which Monday could work out, two in which Tuesday could work out, two in which Wednesday could work out, so on. So that is why there are 2 to the power 5, that is equal to 32 different ways in which I could select a fruit for the week, right? I could select an apple on Monday, a banana on Tuesday. I could end up selecting an apple on Wednesday, an apple on Thursday, and a banana on Friday. This is one of the 32 ways, right? Okay, but but he found the probability of at least 4 consecutive days of apple. So apple I said is H. So at least 4 consecutive days of apple could be HHHHT, right? It could be or THHH and at least 4, which means it could also be HHHHH, right? These 3 are the only possibilities because each one of them has at least 4 consecutive heads, and at least 4. Now look at this, and this is the mistake that you've made as well, and other people also make this, that it is common to include these cases also. Why? Because where T is over here or over here or over here. Why? Because normally the questions of coin tosses, they ask us, okay, in what is the probability that you'll have at least 4 heads, right? In 5 coin tosses. Then we calculate this also. Then we calculate, for example, this also, right? But here I'm given 4 consecutive days, right? So I have to have these 4 consecutive, right? 4 consecutive. So these are not included. Only these 3 cases are included. These are included, and of course, where he would bring a banana on at least 4 consecutive days. So then I have a T, 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 H. Of course, this, same, the image of these where banana is concerned. So, and all T's, right? So 3 these and 3 these. Total, I'll have 6 favorable cases. My probability, which he correctly calculated, will be 6 upon total number of cases is 32. So 6 upon 32. So I'll select 6 over here and 32 over here, right? Right, exactly, Sanket. So that's what I was saying. I thought that you meant the last option, but you wrote it as E. So there are 6 options here, exactly. So 6 by 32, right? That's all. Does that make sense?